So see, first we discussed about the allotropes, which includes diamond, graphite, and fullerenes. Okay, more details about these again you will learn in group 14. Then we also had a graphene, which is same as graphite sheet. How to represent the structure, what is their hybridization, number of bonds, and what type of bonds. This is another segment I discussed. Then, given the structure, how do we figure out how many sigma and pi bonds are there and whether they are in a particular plane or not? How many are in a plane, how many are non-planar? These are the type of questions which was previously asked in JEE, that is to figure out number of sigma and pi bonds in such cases. Then hybridization of every element that is present throughout the molecular structure, right? So in these cases, what are all the hybridizations that they will acquire? This was the next thing I discussed. Now, this was one important area, like to figure out how many maximum number of atoms present in the plane. So if there is any problem in understanding in this case, you can please raise up. Please tell me if you want any discussion on that. I can take one or two more examples, then we can go ahead. Everybody is comfortable with this area? Okay. I don't see any hands raising up here. Right. Next, I also discussed about what is the bond parameters, how they are related. Okay. Single bonds, double bonds. What are the bond angles, how they are related. Then the dipole moment between the molecules. And thereafter, the formula analysis. The formula analysis is mainly to figure out what is the degree of unsaturation. So we figure out one simple formula to find out how much is the degree of unsaturation. Got it? So based on degree of unsaturation, right, this is the generic formula. Considering this is the general molecular formula, here we have CXHYOZ. X is halogens here, then N is number of nitrogen, then sulfur. Putting all of that into uh, structure, the degree of unsaturation can be figured out with this formula. Okay. Based on degree of unsaturation, we also figure out whether it is cyclic, whether we have double bond present, triple bond present, and so on. So we can counter that back from the structure also, that in a structure like benzene, we can have total 4 degree of freedoms because one cycle and 3 pi bonds. That brings total degree of freedoms as 4. Okay. We also discussed how to, break the molecule here. Like for example, in cubene, till you will keep on breaking till it becomes straight chain. So how many cuts we made? 1, 2, 3, 4, 5. So 5 cuts we made, which means the degree of unsaturation is 5. Okay. Thereafter, I gave you an introduction about what are the organic compounds divided into, alicyclic and cyclic, then homocyclic and heterocyclic. Finally, we came across saturated forms and unsaturated forms. Okay. Now, given any structure, we should know in which kind of category we should allocate them to. So like this here, cyclic, homocyclic, aromatic, benzenoid, and unsaturated form. Okay. This is something we should be able to figure out. Clear? Right. Next. I told you that there are, different forms of representation. Representation. One of them is condensed form, semi-condensed form, and functional group positioning. Then structural formula. How do we write the structural formula? Okay. What is empirical formula? What is molecular formula? Finally, how do we write the wedge and dash representation? So wedge means coming out of the plane, dash is going inside the plane. We discussed about the categorization of various carbons and hydrogens. This is the classification. What is the degree of carbons and hydrogens at different positions? For example, this carbon is connected to one carbon. So we call this is 1 degree. This is also 1 degree. And hydrogen is connected to a 1 degree carbon. So hence it is also 1 degree hydrogen. That way you can see there are 1, 2, 3, 4, 5, 6. 6 primary carbons. There are one and only one 2 degree carbon and two 3 degree carbon and four 1 degree carbon. And accordingly, you can check out number of hydrogen. Every primary carbon in this case possesses three hydrogens. So total 18, 2 degree will have 2, 3 degree will have 2 here. So this is the kind of questions we discussed: 1 degree, 2 degree, 3 degree, 4 degree, how many carbons we have and how many hydrogens we have. Okay. We came across another terminology known as allyl, vinyl, phenyl, benzyl. Okay. If there is a carbon which is simply sp2 carbon, we call it as vinyl. If it is sp3 carbon connected to an sp2 carbon, we call it as allyl. If it is sp2 carbon of a benzene ring, we call it as phenyl. If a carbon which is sp3 connected to a benzene ring, that is called benzyl. So these are the four important definitions. And you can notice how many different types of carbons we have: vinylic, allylic, phenylic, benzylic. Okay. Now, this usually confuses because here it is allyl while this is benzyl. So here also the situation is same. It is sp3 connected to a double bonded carbon. Here also sp3 connected to a double bonded carbon. But here this is connected directly to benzene, hence it is called as benzyl as well. So between benzyl and allyl, give preference always more to benzyl. Similarly, between phenyl and vinyl, give more preference to phenyl. Got it? Next, what is the degree of alcohols and halogens? Okay, so for example, if you have alcohol present on the primary carbon, we call it as 1 degree alcohol. Then we have 2 degree alcohol, and accordingly we can have 3 degree alcohol. Same goes with amines. 1 degree amine as in uh, the nitrogen is connected to only one carbon. That is called 1 degree amine. Here also nitrogen is connected to one carbon. Nitrogen is connected to only one carbon. So from amines perspective, it is still 1 degree amine. But from carbon's perspective, here carbon is connected. Here the second degree carbon is connected. Here there is 3 degree carbon connected. But from nitrogen's end, we still call it as 1 degree amine. If nitrogen is connected to two alkyl groups, like in this case, we call it as 2 degree amine. Here it is connected to three alkyl groups, so hence it is 3 degree amine. Okay. Same goes with halogens. And next you notice that hydrocarbons can be categorized into saturated and unsaturated form. Saturated, which we call it as alkanes or paraffins. Then we have alkenes, which are unsaturated, olefins, and alkynes, right, which is also unsaturated form. Okay. Saturated hydrocarbon does not mean it does, it does not mean to have CnH2n plus 2. For example, benzene is also saturated. In a way, it is non-reactive to any catalytic hydrogenation, which means it does not accept H2 to add on it. Then we call it as a saturated form. So benzene is also the same thing. Let me just put that here in writing. Suppose if you have benzene like this, and you're expecting them to add with hydrogen here with some palladium or barium, this reaction does not take place, which means benzene is reluctant to accept any hydrogen and get added. Thus, it is called as unsaturated. It is called as saturated form. All right. This is also saturated. This is also saturated. Okay, not double bond O here, right? So this is unsaturated. If you have a double bond O here, right? Next, if you have C double bond C, C triple bond C, they are all unsaturated forms. Next, the prefix is what we use it, right? Depending upon the connection. Suppose if there is any atom present directly on the benzene, we call it as phenylic group. If any group is present on this position, we call it as benzylic group. Okay. For your reference, you can understand like this. If there is an OH group here, we call it as benzyl alcohol. If there is chloride here, we call it as benzyl chloride. Similarly, if you have two chlorides on the same carbon here, it is called benzal. So this is called benzal chloride, or NCRT also uses this term di. So which means we can call it as benzal dichloride or simply benzal chloride, because the al itself represent that there are two chlorines. Similarly, if you have three chlorines, we can call it as benzochloride or benzo trichloride. Okay. Similarly, if you have phenyl is connected to somewhere, I mean the benzene is connected to somewhere, then you read this as phenyl. And this is one way represent C6H5, PHAR, and this 5. These are all different ways of representing phenyl ring. So phenyl with CH3 on it, that is called toluene. And if you have a phenyl here, we read it as phenyl 2-butane. Okay, so you can write it phenyl this way. You can write the phenyl this way. So this is trityl chloride. Okay, three phenyls with a carbon, that is called trityl. So trityl chloride. Okay. So if you have O phenyl group, that means ortho phenyl group here. So it is connected from the ortho end here. So this is called O phenyl. If meta, that means two phenyls, I mean two groups are connected at 1,3 kind of position, it is called meta. If it is connected at 1,4, it is called para. Okay. If the connection is from this end, you call it as O-tosyl, ortho-tosyl. If it is connected from here, metatosyl. If from here, we call it as para-tosyl. Okay, so you can see this is O-tosyl chloride, O, and this is M-tosyl chloride, and so on. This is trityl. This is called trityl connection or trityl chloride connection. Okay, or trityl alcohol. Acetyl. If you have acetyl, here it is triple bond, so it is called acetylene, common name. And acetyl means it is connected from this carbon's end. So it is connected with the next carbon, which is CH2OH. We call it as acetanilide methanol. Acetanilide methanol. This also used as a suffix here, which is called as propargal. So that is CH2 and then connected with OH. So just like allyl with a double bond, with a triple bond, we call it as propargal. Next, if you have any saturated hydrocarbon and this is its main chain, on a main chain, if there are any groups present, those are called substituents. You can see these are all substituents. So if a substituent is something like a CH4, but after losing H plus, it will have CH3. So that CH3 is connected somewhere here or here like this. Then we read it as methyl. So you can see from C1 to C20, these are all various names we have. So methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonine, decane, undecane, dodecane, tridecane, quadecane, and icos. So CH3 can be converted into CH3 minus, which we call it as methyl, and similarly ethyl. Okay. If R, which is alkyl, is connected to carbon, is sp3. Okay, that is sp3 carbon. That means this carbon is sp3, which is connected to the main chain here. Then we use the word alkyl. Okay, like here, methyl, methyl ethyl, or isopropyl, and this is ethyl. These are all the various names we can give to the substitutes. Now, quickly notice substitutes can also be named with terminologies like iso, neo, secondary, tertiary. If this is 1, 2, 3, 4, this is simply called as N-butyl or simply butyl. N-butyl, that means naturally occurring butyl. So next, isobutyl. This means in the N-butyl, if you take this methyl group and add it to the second position, that is called isobutyl. Now here you can see N-pentyl, and if I bring it here and put it here, that will become isopentyl. If the connection is already from the second carbon, so that is called as butyl, secondary butyl. If it is like this, then it is secondary pentyl. This is secondary propyl. Secondary propyl also has another name, which is isopropyl. This is only propyl connected to it. Next, if you notice this 4 here, so this is tertiary butyl here. Okay, here it is tertiary pentyl. So this is tertiary butyl and tertiary pentyl connection. Okay. Tertiary is formed basically when you have two alkyl groups are connected closest to the carbon here, to the closest carbon. Okay. We can read this as neopentyl. This is called as neopentyl. So check this out. These are the names to be used. Iso or secondary propyl, secondary butyl, isobutyl, tert butyl, and neopentyl. Okay. Now notice the common names. Okay. So if you have this is pentane, hexane, isopentane, isohexane, neopentane, neohexane, tert-butane. These are all commonly used. Okay. If at all they have functional group also, we can still use the same. Got it? 1 second. Sir, why are tertiary butyl and pentyl called tertiary? Okay. Tertiary is because it has three connections on it. See, for example, if you notice this carbon is connected to three more carbon. Correct? Understood. Sorry, here it is connected to, I meant to say only this part. This part is tertiary, like here. You can see this is connected to the main chain. And that carbon has how many attachments? Three carbon attachments. So that's why it is called tertiary. Here also, this carbon has one, two, three attachments. So hence it is tertiary. While if you look into this one, actually this is only single carbon connected here, but this single carbon is again connected to three more methyl groups. So if you have to count this as the entire unit, then you use the word neopentyl. Okay, right. Next, these are all the common names that you can write down. Here, for example, this entire thing I can write it as neopentyl alcohol. Here, this is at secondary position. So, active secondary pentyl alcohol. Okay. This is secondary pentyl alcohol. Correct. See, if the secondary is inside, usually we call it as non-active or simply secondary. Though if it is at the secondary position, that is called as active secondary pentyl. This is tert pentyl amide. This is secondary propyl bromide. You can say this is 1, 2, 3, 4, 5. So it becomes isopentyl chloride. Okay, sorry, if this is amine, because I have written it as amine, I'll write it as NH2, isopentyl amine. And then we have OH here. Then we have OH here. So isopentyl alcohol, isoamyl alcohol. Okay, so these are all the common names which you can check. Next, when unsaturated carbon is directly connected with a single bond, then you can name this 2 carbon as vinyl. If you have 3 carbon, it is propenyl. If you have a single bond only connected and at the terminal side we have a double bond, it is called allyl or prop 2 enyl. Here, this is called ethinyl. Carbon connected directly to 3 carbons, that is ethinyl. Okay, so you can see it is but 2 ein y yl. This is prop wine yl. And here CH2 with a double bond, if it is connected, it is read as lydine. This is important, everybody. Check it out. CH2, if it is directly connected to the main chain, it is read as methylidine. So if you have 2 carbons, it is ethylidine. If you have isopropyl, you call it as isopropylidine. Okay. Now notice from here, everybody. If you want to make a general naming for an organic compound, what are all the terms you should know? Organic compound usually have these 5 things. Is it necessary to have 5 things? Not necessary. For example, my name is quite bigger, but for a regular use, correct, I made it little. I mean, for general usage, I usually call myself Anil Kongati. That's it. Clear? But I have some middle name. I have some surnames also carrying my grandfather's name and all of that. But we don't use it anymore. Correct? So like that, this is optional. Clear? So some things are optional in here, some things are must. For example, we call our first name. First name is a must thing to do, right? So same thing. Root word is like the first name. Everybody, that is must. That we have to definitely express. Clear? And secondary suffix. Secondary suffix is a must name again. Clear? These two we have to definitely represent. Rest all are optional. Correct? So sometimes you might be using primary suffix or not. Sometimes primary prefix, sometimes secondary prefix. Okay, clear? But what are the two important things? Root word and secondary suffix. These two are compulsory for a naming. Now notice functional groups. If you have a carboxylic acid, right? Structurally, it looks like this, RCOOH. Every functional group will have two names to it, IUPAC names. One, when it is used as a prefix. That means it is not a functional group, but it is like a substituent. Then carboxylic acid is called as carboxy. But if it is used as a suffix, that means as a functional group, when it is used, we use it as oic acid or carboxylic acid. Both can be written in different situation, different scenario. We will use these two. Similarly, sulfuric acid, prefix is sulfo, suffix name is sulfonic acid. This is sulfonic acid. Similarly, acid anhydride, C double bond O, C double bond O here. So this is called acid anhydride. Okay. There is no prefix to it. This is important to understand. The only functional group which does not have a prefix name is anhydride. Anhydride does not have any prefix name. Okay. As you go ahead and start writing, you will realize why it does not have it. Okay. Then esters. When you have esters, the suffix name is OAte or carboxylate. OAte or carboxylate. The prefix name is alkanoyl oxy. We use the word alkanoyl oxy. Alright. When to use it? This one, I'll show you through some examples. Acid chloride. The suffix name is OL chloride or carboxyl halide. Prefix name is halocarbonyl. The prefix name which you use is halocarbonyl. Next, acid amides. Amides are like this. Structurally, C double bond of NH2 if it is there, 1 degree amide. If there is alkyl present on nitrogen, it is 2 degree amide. If there are two alkyl present, you call it as 3 degree amide. So prefix is amido or carbamoyl. And prefix is amido or carbamoyl. Suffix is amide or carboxamide. Amide or carboxamide. Next one, structurally this is cyanides. Prefix is cyano, suffix is nitrile or carbonitrile. Isocyano, prefix is isocyano. If you have NC instead of CN, if you have NC, it is isocyano. Or suffix is isonitrile. Aldehydes. Aldehydes can be used as aldo, formyl, oxy or oxo. Next, as a suffix name, we use the word al or carbaldehyde. Al or carbaldehyde. Ketones, the prefix name can be used as oxo and keto. Suffix name is one or one, O-N-E, one. And then we have ROH, alcohol. You know, if you have any alcohol here, so that is represented as hydroxy. The prefix is hydroxy. Suffix is all. Suffix is always all. Thioalcohol. If you have RSH, the prefix name is mercapto. Suffix name is thiol. Okay, just like all, it is thiol. Prefix name for amines is amino. Suffix name is amine. C double bond NH functional group, if you notice, it is called imino and suffix name is imine. ROR is not a functional group. From here, you can see ethers, nitro, nitroso, and halides. These are not considered as functional groups. So structure ROR will have alkoxy and suffix is not clear. If it is alkenes, C double bond C, then we call it as alkenyl in case if it is prefix. Suffix is ene. If you have triple bond alkyne yl, suffix is ine. Okay. Now these are all only substitutes. They do not have any suffix, secondary suffix name. So halogen Rx, if you have X is represented as halo. NO2 nitro, NO nitroso, N3 minus azido, N double bond N R, that is diazo. This is called diazo. N double bond N is also called as diazo substituent. Okay, these are all various substituents, everybody. Now, when it comes to priority order as in the order of preference in terms of functional group. Okay, this I want all of you to practice it once, write and practice, everybody. First preference is always to acids, carboxylic acid, then sulfonic acid, then we have anhydride, then ester, then acid chloride, and so on. Okay, just a minute. So this is the priority order that you should remember, right? As in functional groups, how it is to be used. Next. When it comes to alkenes and alkynes, how do we prioritize? Okay, see, generally, always, alkenes are more preferable than alkynes, considering locands are same. What do you mean by locands? That means the numbers which they are getting. For example, if I go in this direction, if I start numbering, I'll, main parent chain in this direction, 1, 2, 3, 4, 5, 6, 7 in this direction. So here also I'm getting alkene at 1, 2 position. If I go the other way around, like this 1, 2, 3, 4, 5, 6, 7. Here also I'm getting it as 1, 2. So when triple bond and double bond, both of them are positioned at the same side from different sides, from different reading of the functional group. In that case, we will give more preference to double bond. Basically, it is based on alphabetical order. Alphabetically, E and E. E come first, I, Y comes last. Okay. So that's why E needs to be more preferred. Correct. Now, this is one very important JEE mains question that is usually asked to you to figure out how many number of functional groups are present in the following. Correct? Everybody, let's try doing it together. Check it out how many we have. See here, I would say, correct, this is an amide. If you can notice, C double bond ONH, that is one amide group. Clear? So let me mark that. This is amide. One. Then you can see here there is ketone. This is ketone. Correct? And then we have secondary amine. This is a secondary amine. And then we have alcohol. This is alcohol. Alcohol is a different functional group. Then you can see there is an anhydride. This entire thing is anhydride. Clear? So how many different functional groups we have? 5. So we got 5 different functional groups. I suppose all of you understood this point. Right. Next. Check out the next one here. You can see this one is an ester. This is ester. Then this one is ketone. This one is ketone. The next one is ketone. Okay. The next one is aldehyde. This is aldehyde. Okay. The next one is carboxylic acid. The next one is acid chloride, different functional group. The next one is again an ester. This is also an ester form. Clear? So ester functional group is repeated. That's not different functional group. So how many we have total? So total, if you notice, 1, 2, 3, 4, 5. So total we have again 5. So 5 functional groups here. Correct. Next, see the next one here. We have this one is primary amine and the next one is ketone. Correct. Now, this one is secondary amine. Remember, primary amine and secondary amine are two different functional groups. They are not same functional groups. Then thioalcohol, different functional group. This is amide. Amide is one functional group. Okay. Then you can see alcohol, another functional group. Correct. Then you can see another amide. This is the same amide which is there. And then aldehyde, another functional group we have. Correct. So I'm removing that amide form. The rest of them you can notice how many we have. So check it out. We have 1, 2, 3, 4, 5, 6, 7. But there is one more which is hiding. What is that? This one, double bond. Double bond is also a functional group. Correct? So you have to count that as well. So what should be the answer? 9. Utsa, is it gone now?
Yes, sir.
Yeah. Next. Check out on the fourth one now. Right? One second. This is appearing again and again. Close the other windows. Yeah, I should not see that. Right. Check out the next one here. Here we have a triple bond. Triple bond is one different functional group, correct? Then we have, secondary amine. Then we have ketone. You can see this is ketone. Then we have ether. Ether is one functional group. Okay. Then this one is important. This entire thing with benzene and OH together is called phenol. Phenol is a different functional group, correct? And then amide. Amide is a different functional group. And then alcohol. So far we didn't get alcohol. Alcohol is a different functional group. And then acid chloride, another different functional group. Correct? So if you count it, how many we get? 1, 2, 3, 4, 5, 6, 7, 8. So total we have 8 different functional groups. Everybody clear? So any given compound, please make sure that you are aware of all the functional groups. Okay? Clear? Now, what I would suggest is whenever you are trying to write this, please either recall it. If you are not able to remember it, my request is you better write down the names also in front of it. If you have book and pen, if you have already took the printout of it, please make sure that you write the name of that function group in front of that, so that you get a habit of knowing that exactly what does that mean. Got it? Chalo. Next, let's see these cases. See, first, the rules for IUPAC, especially for alkanes, only for alkanes. What it is? When you have only alkanes in the chains, try to find out the longest carbon chain first. That's your first job. So here you can see 1, 2, 3, 4, 5, 6. So I could have gone this way also 1, 2, 3, 4, 5, 6. While choosing the longest chain, try to make sure that the substituents are always at the lower numbering possible. Now here you can see 3 and 4. But if I go from here, 1, 2, 3, 4, 5, 6. I think here also you can get 3 and 4. So you can go this way, or you can get this way also. 1, 2, 3, 4, 5, 6. Both of them are correct. There is no problem with that. One of them will be right when you choose which substituent is more prioritized. Now listen up. When it comes to this kind of cases where the substituents are same, I mean the locant numbering of substituents is same, then the one which is starting with the nearest alphabet, that should be given more priority. Like this substitute's name is ethyl, this one is methyl. So alphabetically ethyl should come first. So which one is correct way of representing the green one? Okay. So this one is the wrong way of representing in that case. Sorry. Clear now? So that's how you figure out the longest chain. Check out the second one. In case of the longest chain, select the chain with maximum substitute. That means you got a longest chain already, but you have to select which one has the maximum substitutes. For example, check this case. If I go this way, everybody look into it. 1, 2, 3, 4, 5, 6, 7, 8. This is also 8 length. The given one is also 8 length. But on this length, the blue one which I'm holding right now, here how many substitutes has there? 1, 2, 3. You have how many substitutes? 3. So if I go in the path of this blue color, I will get 3 substitutes. What if I go like this? If I go like this, I will get 1, 2, 3, 4, and this entire thing as 5. So how many substitutes I'm getting? 5. So since I'm getting 5 substitute, this is the direction you will go. The second rule is clear. Next. In case of branches, right? Choose the direction of the numbering where the branches are at the lowest numbering. This I told you already. So I could have gone in this direction. I could have gone in this direction. But from right to left, when you go from here to here, you will see the lowest numbering. The numbering is coming at 2, 3, and 8. While if I would have gone it from here, I would have gone it at 2, 3, 4, 5, 6, 7, and 8. So you can see if I go from left to right, I will get it as 2, 7, and 8. If I go from right to left, I will get it as 2, 3, and 8. So this one, what I have written already, is the lowest locant direction. Next. Next one is the lowest first point of difference in giving primary chain. For example, if you go from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? While going from this end, I'm getting it at 2, 7, 7, correct? This is the way I'm getting. Now, if you go from left to right like this, okay, left to right like this, in that case, what I'm getting 3, 3, and 7, okay, clear? Usually, in school, what it been taught is that add all of them, see the lowest sum. We should never see the lowest sum, correct? Basically, you should compare at every position, whichever is coming at the lowest point of view, lowest first point of difference. See, here itself, the point of difference is observed. Here it is starting from 2, here it is starting from 3. Now you don't have to compare the rest at all. Then you have to choose the direction from the one which has the lowest numbering to start with. That's it. So this is where I got the first point of difference. There itself, it is decided this one is the correct priority. So that is right to left is the correct priority. So I'm guessing all of you understood this part, what I'm trying to say. Clear? Right. Next. In case of locants, always, same number of locants follow the alphabetical precedence of the substitute groups. This I told you already. From left to right, if at all I go, I'm getting it as third number. If I'm going from right to left also, I'm getting it as third number. So this is also at third, this is also at third. If both the locants are coming same, then whichever alphabetically comes first, prefer that. So this is it. That is what you will prefer. Okay. So everybody, the first five rules are clear. This is mainly to be checked for alkanes. Okay. Done. Now come to the next one. Comparing the straight chain versus the cyclic chain. If you have straight chain versus the cyclic chain. So if you have two chains compared here, cyclic is 3 carbon here, straight is also 3 carbon. In case the number of carbons of cyclic and acyclic are same, the priority is always given to cyclic. Okay. So you will start numbering from 1, 2, 3. So which is incorrect numbering here? So this one, this one, 1, 2, and 3. This one is incorrect numbering. Everybody clear? See the second case now. The second case, you have 4 here and 3 here. So definitely what numbering it is given is correct. So if cyclic is greater than acyclic, no question, cyclic is more priority. If straight chain is longer than cyclic chain, then straight chain is more prioritized. So you can see acyclic is more prioritized than cyclic. Okay. Now notice if both of them are same, but number of branches are more for acyclic, correct? Whichever in fact has more number of branches, that should be given more priority. For example, 1, 2, 3, 4. Here 1, 2, 3, 4. But in the acyclic structure, that means straight chain, you will have 1 and 2 substitutes. But for cyclic, you have only one substitute. This entire thing is one substitute for cycle. Therefore, this 1, this 2, this 3, and 4 are incorrect. The correct one is with the straight chain. I guess this part is clear, everybody. Done. Right. Let me start writing the names and learn it. Okay. We'll keep writing learns and name it, everybody. Keep doing it along with me. Everyone, please do it. At the end, I will ask you to send you the notes as well. So please make sure you are doing it together. Okay. Check. From 1, 2, 3, 4, 5, 6, 7. I could have gone this way. I could have gone this way. So based on the lowest locants, I'm going from left to right. Now, while naming it, you can see on third position I have methyl, fourth position I have methyl, fifth position I have ethyl. So the common ones you can club it like this: 3, 4 dimethyl, and 4 at 4 position we have ethyl. So see, you should never compare what it is present with the numbering alphabet. Numbering alphabet should never be compared. You should only compare with the name alphabet. So myth versus eth. So M versus E. In M versus E, definitely E is more prioritized. So therefore that should be written first. So 4 ethyl, 3 comma 4 dimethyl. And what is this one? 7 one is heptane. Everybody, I hope all of you have written the name. देख इश्मन, ऊपर नीचे लिख दिया ना, वो इंपॉर्टेंट है. Okay. Ethyl should come first, beta. Next. No, Ishman, we don't see which come first. While writing the name, alphabet is the most important criteria. Okay. Right. See the next one. Everybody, I hope the first one is clear. See the second one. I have decided that this is the direction based on the lowest locants. Correct. So I'm not trying to make you solve which is the correct chain, which is the long chain from left to right or right to left. That I'm giving it to you. Don't worry. You try to figure out what is the name that is supposed to come. Check out. Here there is an ethyl and ethyl, and then there are three methyls. Correct? So how do we name it? First ethyl should come. So 2 comma 6 diethyl, then 3 comma 4 comma 4, that is trimethyl. Then we have trimethyl. Then this is octane, 8 carbon, so it is octane. Correct, beta. Let's try doing the next one here. You can see you have to start the numbering from here only because it has two branches. Two branches you can get directly 1 comma 1 comma 3. So these are the substitutes. So that is the lowest locants which you can handle. Correct. So here also we can write it as 3 ethyl, 3 ethyl, then 1 comma 2 dimethyl, 1 comma 2 dimethyl, cyclohexane, cyclohexane. Got it? So I hope all of you got that. 1 comma 1. Sorry. I wrote it as 1 comma 2. Sorry. 1 comma 1. Clear? Now, notice this in this particular name. Okay. Right, Tanish. Correct. Next, in this particular name, everybody, this hex represent root word. Correct? Cyclo represents primary suffix. Correct? And all these substituents represent primary prefix. This all represents primary prefix. Correct? So this ane is that, secondary secondary prefix, correct? But in the case of alkane, there is no functional group as such after that to repeat. So secondary prefix and secondary suffix, both of them are same in the case of alkane. Got it? Clear? Right. So let's try the next one. See, next one, I think a lot of you have written it already. Let me write down that here. So 2 ethyl, so it is going to be 2 ethyl 1 comma 3 dimethyl cyclopentane. ओके, अब थोड़ा फास्ट लिखना स्टार्ट कर दो सब लोग. सो स्टार्ट पुशिंग अप लिटिल फास्टर एवरीबॉडी. राइट उत्साह, दैट्स राइट. तनिष, गुड वन बेटा, कीप गोइंग, यू राइट. See the next one, 1 comma 3, okay, diethyl, 1 comma 3 diethyl, and then on fourth position I have methyl. Fourth position I have methyl, and this is cyclopentane. This is cyclopentane. Clear? Right. That's right, Utsa. See the next one. Okay. While you're going in this direction, I mean, you have to decide this direction or this direction. Alphabetic, because locands are coming at same position. Everybody see locands kahan se aa rahe? One, you are getting 2, 3, 5, 6. This is 2, 3, 5, 6. If I go from right to left, 2, 3, 5, 6. Again, you're getting the same locants. That means you have to go alphabetically. Alphabetically, Br, bromine will come first. So that is the direction you will decide. So 1, 2, 3, 4, 5, 6, 7. This is the numbering. Okay. So now, what do we name it? So because alphabetically bromine come first, so 2 bromo, then 6 chloro, alphabetically chlorine come after that. Then we have 5 methoxy, O alkyl is always called as alkoxy. If it is methyl, methoxy. If it is ethyl, ethoxy, and so on. NO group is called nitroso. Nitroso. NO2 hota hai, then it is nitro. That's the difference. Remember, nitroso. This is nitroso heptane. Nitroso heptane. Nitrosil is not used in this terminologies for strict IUPAC. It is not used nitrosil beta. Okay, Tanish, clear? Right. Next. Now coming to little unsaturated. Quickly, let's go to the rules again. Got it? When you have unsaturated form, choose longest chain which has maximum number of unsaturated bonds. That is the most important part. You have to choose the longest chain which contains the maximum number of unsaturated bonds. Correct? So here you can see 1, 2, 3, 4, 5, 6, 7. Clear? 1 minute. Yeah. Next, check it out. Choose the longest chain which has the maximum number of unsaturated bonds. And then always give least numbering to the unsaturated bonds. Then maximum double bond or triple bond with the lowest locants first, with the first point of difference that you need to check it out. Clear? Got it? So now let's try to assign this, how we can get what is the longest chain. And uh, first I would suggest you to try writing the numberings, everybody, for 2, 3, 4, 5. While writing this, what is the parent chain? Please try to fix that. What is the parent chain? Right? Let's try to assign the numbering first, everybody. So if you notice the first case, I think you got an idea where to number it. Now here, check out, if at all I go like this, like this, like this, like this, I'm covering three uh, pi bonds, correct? But see the numbering what it is, 1, 2, 3, 4, 5, 6, 7. So basically the locants which I'm getting it as 1, 4 and 6. 1, 4, 6. These are the locates I'm getting. Okay. So I'll just write down here 1, 4, 6. What if I go like this? If I go 1, 2, 3, 4, 5, 6, 7, 8. Here also I'm getting 8 only. 1, 2, 3, 4, 5, 6, 7, 8. Here also I'm getting 8 only. So you can see. Now you can see the locants 1, 2, 3, 4. Let me write down that. 1, 2, 3, 4, 5, 6, 7, 8. So locants are coming at 1 position, 4 position, and 6 position. Correct? Here also I'm getting the locants at 1 position, 4 position, and 6 position. Isn't it? So either you go this way or you go this way, you're getting at the same position. Okay. No, I think 1 second. Let me see again. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Here I'm getting 1, 2, 3, 4, 5, 6, 7, 8. Here I'm getting it as 7, not 6. Sorry. At 7 I'm getting. Correct. So in the second case, if you notice, I'm getting it as 1, comma 4, comma 6. So which one to be preferred? Like this. This is the order that need to be preferred. So therefore 1, 2, 3, 4, 5, 6, 7, 8. So this is the correct order. Everybody clear with the numbering? See the second one. If I go from this end, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if I go with the numbering again, 1, 2, 3, 4, 5, 6, 7, 8. See where are the numberings getting? 1, 3, 5, and 7. 1, 3, 5, and 7. These are the locants numbering which I'm getting. If I go the other way around, check it out. 1, 2, 3, 4, 5, 6, 7, 8. So you are getting at, uh, where I'm getting 1, 2, 3, 4, 5, 6, 7, 8. So you can see I'm getting it as 1, 3, 5, 7. 1, 3, 5, 7. Sorry, here also I'm getting it as 7. So basically on both sides it is same. Everybody. Both sides we are getting the same locants. When you get the same locants, I told you what should we prefer between double and triple bond? Double bond. So therefore 1, 2, 3, 4, 5, 6, 7, 8. This is the correct order. Clear? Next. You have 2 here. So numbering will be decided like this. 1, 2, 3, 4, 5. Correct? I hope all of you got that. Now, I will come back to these rules, what I have written it here, correct? While writing the IUPAC naming, I'll come back to that and tell you what is the rule exactly. Okay. So let us start writing first. Everybody, let's start writing. First, figure out. This time you also have to figure out what is your parent chain, everybody. Start working on the parent chain as well. Okay. I'll help you with the first one. 1, 2, 3, 4, 5, 6, 7. This is the maximum number of length I can get with maximum double bonds. And alphabetically also 1, 2, 3, 4, 5, 6 only I'm getting. So definitely this is the correct route. 1, 2, 3, 4, 5, 6, 7. 3 and 4 has substituents. Alphabetically, fourth substituent should come first. So therefore, the name would be 4-ethene-yl, 4-ethene-yl, and on 3 position I have methyl, correct? And hence this is hept. Now this is the rule that you need to follow. Check out on 1 position, 6th position, I have double bond, correct? 1 position and 6th position, I have double bond. If you have multiple double bonds, you will write it as hepta, not only hept. So this is important when to use that A, okay? So I'll be using this A here, hepta. Hepta, then 1 comma 6 diene, okay? That is the rule I was talking about. So if you have plural or multiple double bonds or triple bonds, you will use the word hepta like that. Okay. And I guess all of you got that. See the second one, next one. Write the numbering, everybody. See, I'm based on, how it looks like. This one looks longer, little longer chain like this. Correct. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So this one is longer. So I would go from here 1, 2, 3, 4, 5, 6, 7. Got it? So if this is the case, what is the name I will get? Here this is 4th position. I have ethine and yl. That is a ethyne group which is a substitute. That's why it is called yl. Ethyl. Then on 6th position, I have 1 methyl. So it is methyl. And similarly, and on 3rd position, you can see under 3rd position, I have methyl. Okay. On 3rd position, I have methyl lidine. Methylidine. Now, you might be wondering, sir, which one should be written first? Methyl पहले लिखना चाहिए या methylidine पहले लिखना चाहिए? See, whichever has a name ending, you always write that first. Okay, methyl is ended, the name is ended. But here the name is continued. So name continued as in again you are going back to that ABCD order. Clear? So that means they should come first. Right? Clear? Sorry, I meant to say this one. This one should be ending. Ending means it is ended with that Z, something like Z. So you are comparing like here Z versus the M. Clear? So that should be written first. Okay. Next. Methylidine is done. Then again I'll write hepta because there are 2 of them. Hepta 1 comma 5 diene. Refer to it, everybody. Ishman, please check it out, beta, if you have understood this or no. Tanish, notice it's not benzene, beta. It is just open cyclohexane. Now listen up. When you have a double bond, that should be the priority. So it doesn't matter whether you have a cyclohexane, anything. Correct? So straight chain now acyclic structure will become the main chain here. So 1, 2, 3. So the chain length is only 3. And now here you will write it as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Okay. Then you will write it this way. On the 3rd position with a bracket, when you have multiple numbering schemes, you will write it in bracket. Then you will write it as 2 methyl. In the bracket, you will write it as 2 methyl. And this is cyclohexane, which has become yl. So this is 3 methyl cyclohexyl. And then we have prop 1-ene or simply propene. Clear? See, usually while writing IUPAC naming, this 2 dash is not preferred much. Okay. The 2 dash 3 dash is preferred when you have too many rings, multiple rings if you have. But otherwise you can simply write it as 2. Why I'm showing it as prime 1 prime 2 prime and so on is because to differentiate that there is two numbering system. Okay, but while writing you can just simply write it as in bracket with that number. Correct. Now notice here, when you have two main chains here, see here outside it appears like double bond should be given more priority. What does the first three stands for? The first three stands for this one. On third, this is your main chain, right, Tanish? On that third position, ये पूरा substitute है. Okay, right. Next one, notice when you have double bonds outside which are multiple numbers, so it becomes difficult कि किसको हम लोग main chain माने. 1 2 should I call this one? 1 2 should I call this one? In such case, you will not take that double bonded form as main chain. You will take this cyclohexane as the main chain itself. So now it will become 1, 2, 3, 4, 5. Correct? Now you notice on 1 comma 2 position, I have diethynnyl, and this will become cyclopentane. That will become cyclopentane. Clear? So that will become cyclopentane, everybody. Next. Again, here if you write the longest chain, this will be 1, 2, 3, 4, 5, 6, 7. This is the longest chain which you have. So you can see on fourth position, you have cyclopropyl. So when you are using the word cyclo, right, this will come into the alphabetical precedence because that is not a numbered form, right? Cyclo का मतलब कोई number नहीं होता है. So that's why you have to use that for comparison of alphabets. Okay. So it is supposed to be 4 cyclopropyl. Then we have 3 ethyl. Then we have 3 ethyl. Then we have hepta and 1 comma 6 diene. 1 comma 6 diene. Got that, everybody? Finished? Right. Now notice this one. See, this structure can be written in so many different ways, different names. First, let me put the numbering. Numbering will always be the same. So 1, 2, 3, 4, 5, 6, 7. This is 7 carbon. And now within that we have more branching. You have 1 dash, 2 dash, 3 dash. Here again we have 1 dash, 2 dash, like this. Within them we have branches, multiple branches. Clear? So now while writing it, suppose if at all I'm writing with all the numberings, so what I'll do, on fourth position I have 1. Within that, see, within this fourth position I have, on one position I have methyl, but it is actually an ethyl group. So 1 methyl, but it is actually an ethyl substitute because on that ethyl there is one more branch which is methyl. So you write it as 1 methyl ethyl. And similarly, on third position, I have one. On third position, I have one methyl. Correct. I have one methyl, and this is supposed to be propyl. Okay, methyl propyl. See, what are the alphabetical precedents I have used? First, I have used, sorry, first I have used E here versus P here because दोनों में methyl common है. Both of them have methyl common, so that's why I use that E versus P. Correct. Then I have hepta. Correct. Then 1 comma 5 diene. This is the way you can write down. Clear? And Remember this as a group, we can also call, instead of writing in bracket, right? We can also call this as secondary butyl, right? So sec butyl, this can be called as sec butyl. Similarly, this can also be called as two different names. This has two different names. One is sec propyl, because it is a secondary propyl, and sec propyl, as well as this is isopropyl. This is one important thing to understand. In the case of propyl, sec propyl, secondary propyl, and isopropyl, both of them are same. Okay. So let's say this option is not given in the question. In the question, this is not given. Then you will search for secondary kind of, representations, right? So let me write down this way. On third position, I have sec butyl, secondary butyl, clear? And on fourth position, okay, but this should come later, my mistake. On fourth position, I have isopropyl, okay? So I can write it as fourth with isopropyl, correct? This is isopropyl. And now notice this is very interesting. I have three sec propyl and isopropyl, correct? And if you are reading these two, secondary propyl and isopropyl, now tell me alphabetically which one should come first. Actually, this bracket is also not required anymore when you are writing it as isopropyl, correct? Now, this is very interesting. When it comes to this one, check ISO. Is ISO a numbering system? No, right? ISO is not a numbering system. Okay. But secondary is a numbering system. Second, it is a number value, right? That's why here, while taking the precedence, you will consider I of isopropyl, but B of secondary butyl, not S of secondary butyl. Clear? Everybody understood the precedence? Right. So therefore, what should come first then? 3 secondary butyl only should come first. Then line here. So 3 secondary butyl, 4 isopropyl. Then what do we have? Hepta. So we have hepta 1 comma 5 diene. I guess this is clear, everybody. What if instead of using iso, I use the same secondary here? So it will become sec propyl. But still, alphabetically, in that case, what do we prefer? P versus B is what you will prefer. So let me write down that name also. This entire thing, let me copy here. So in that case, instead of iso, now I'm using sec, a secondary. So sec propyl. So in that, the precedence is actually P versus B. So P versus B, still the B is coming first. So these two are the correct names to write. Everyone understood this point? Check. Next one. Now listen, here we have, this is isopropyl. This is also isopropyl. Whether you can read it as secondary butyl or secondary butyl, correct? If you have two common complex, these are called complex substituents, by the way. These are called complex substituents. If you have complex substituents, well, first write the parent name, parent numbering 4, 5, 6, 7, 8. And you notice that on fourth position and on the third position, at these two positions, we have a same group repeated. If you have a same complex group repeated, then you will use the word bis, tris, tetrachis, and so on. This is the Greek numbering that we need to use, which is C. On fifth position, I have methyl. Let me write down that first. Correct. After that, we have bis 3 comma 4, right? Then we have 1 methyl, one methyl ethyl, and you have one methyl ethyl, and then we have octa 1,6 diene, 1,6 diene. Clear? Now check it out. This is again a numbering system. So that is not going to come in the alphabetical precedence. Clear? So now what do we need to check out? We have to check out with M versus M. Because now you might say, why are we not comparing E here? Correct? Now listen up. The minute you put it anything in bracket, right? When you put it in bracket, then you don't see what is the substitute within the substituent. You will simply see what is the first alphabet it is starting from. Even if you have a die, try something, still you will consider the D. You'll consider that, you will write that with the D word. Okay. So you will compare with the D versus the other element. Okay. So remember, in the bracket, you will not see whether it is a numbering system or it is a name system or anything. You can simply consider what is the first letter that is coming when it is in the bracket. Okay. I guess all of you understood this part. So this is a word that you need to use in case if you have same groups repeated. Correct. Now notice this one. When you have, any of these cyclic structures given, numbering becomes such a challenge. So notice that carefully and let's start numbering
Sir,
here. Amita.
sir, why does that? I didn't understand why the methyl comes before methyl ethyl.
Why does methyl come before methyl? Okay. So basically it is like this. When you have methyl here, right? And then after we have a methyl and then E is starting, isn't it?
Yes.
Correct. It is starting with E. Correct. But when the name is ended, what is the next alphabet? There is no alphabet here. When there is no alphabet, we'll assume that it is starting with A again.
Okay. Okay.
So it is like you are comparing A versus E again, correct? So which should be given priority? A.
A. Right.
Next, check out these examples here. First one, bromine, chlorine, we have two double bonds here. Remember, double bond should be given the highest priority always. So numbering will go like this. 1, 2, 3, 4, 5, 6. The advantage is here bromine is also getting a lower numbering. So we are getting the lowest locants. At the same time, we are able to keep the double bonds at the lower numbering. Okay. See the second one. Where do we start? Actually, we can start counter clockwise also. We can start counterclockwise also, which means I can start from here 1, 2, 3, 4. So I'll get substitute at 2 and 3 position, or I can start 1, 2, 3, 4. Here also I'm getting substitute at 2 and 3 position. So if you have same substitute, give the alphabetical precedence as the first priority. So it is 1, 2, 3, and 4. So bromine is at the second position. All right. So bromine is at the second position, everybody. Next one. Here you see, for these kind of cases, first preference is always about lowest locants. The lowest locants you can get it when you have chlorine started, then bromine, iodine, and so on. This is the lowest locants. Here the lowest locants will be from iodine. 1, 2, 3, 4, 5, 6. The next one, all of them have equal preferences. So if I start with bromine also, I'll get 1, 3, 5. If I start with chlorine also, I'll get 1, 3, 5. If I start with iodine also, I'll get 1, 3, 5. So you are not going to get different locants. If you don't get different locants, then alphabetically you have to go. So first bromine, then you go towards chlorine because alphabetically again next after that chlorine will come. Clear? Next, making sure the double bond gets more priority here. So we'll start from here, go, counterclockwise. So 4, 5, 6. This is the numbering. Next, after that, we need to give double bond the high priority, correct? So if I go this way, you will get 1, 2, 3. On third position, I can get 2 substitutes. So that is better. So I will go like this: 1, 2, 3, 4, 5, 6. So double bond at the lowest values, if you notice, it is 1 and 4. Next is giving double bond the more priority group. Clear? So if I start from here, 1, 2, 3, 4. This one is producing lowest locants. 4, 5, 6. Check. Next one. Again, giving the double bond the more priority here. So we'll start from here. 1, 2, 3, 4, 5, 6. Next one, the lowest locant is coming with a dichloride here. So you'll start with here 1, 2, 3, 4, 5, and 6. Last one, going from here 1, 2, counterclockwise 1, 4, 5, 6. Here you are getting the least locants. Anyone has a doubt with these cases, they can please refer back to me. Done? Everybody finished? Shall we go ahead? Ayushi, any doubt, bacha? Okay. Let's see in the next one. Find the longest chain having the maximum number of functional groups containing double bonds and triple bonds. That's the main rule you have to follow. With the functional group and double bond, that will always be your main chain. Double bond or a triple bond. You do not look out for simply a longest chain. You have to check out whether it is with the functional group and with maximum double bonds or not. Okay. So these are all the namings for monofunctional groups. Let's see. So priority wise, if I have to give functional group in the first case, alcohol is a functional group. The lowest functional numbering which I can give is like this. So 1, 2, then 3. I have to go towards double bond. Don't just simply look into longest chain. Okay. You must have the longest chain possible with maximum double bond or triple bond groups. So this will be your main chain, everybody. चलो साथ में नाम लिखते हैं everybody. Let's write the name. So what do I get? 3. Please be quick, everyone, and try doing simultaneously. 3 ethyl but 3 in 1 all. 3 in and 1 all. Okay. Now Notice this something very important here. While writing in, I didn't write this E. I didn't write this E. Correct? When do we delete that E? You can remove that E when the next alphabet followed is a vowel vowel sounding. Okay, vowel sounding alphabet. Correct? That is A, E, I, O, Y. U will not come usually, but Y is something which sounds vowelish. Correct? So that's why any of these is there, then you can remove this E out of the naming. Okay. If any consonant is followed, definitely you have to keep that E. Okay. See the next name now. So while numbering, or where do we give it? Check. You have to give OH double, I mean the priority here. Alcohol should be priority, but double bond should also be given the priority. So maximum alcohol can get is only on third position. Irrespective of however you go, you'll only get at third position. So this is how you have to write. So now you can see what do we write here? So 2 comma 4 dimethyl 2 comma 4 dimethyl, and this is pent basically. So we have pent, okay, penta 1 comma 4 di n. I didn't write in again. Di n 3 all. Di n 3 all. Check if you got that correct, everybody. Next one. The priority should be to ammonia first. So you have to start numbering from right to left. You have to start numbering from right to left. So the name would become pent. So it is pent 4N 1 amine. 4N 1 amine. Sorry, 2 amine. 4N 2 amine. Next, see the next one here. See, this is very interesting one. Again, you have to give priority to alcohol. So you start numbering from here 1, 2, 3. Now you are confused whether I should go, towards double bond or toward triple bond. Towards double bond or triple bond, you are getting at the same locants, first of all. But at the same time, have you noticed that towards the double bond, you have a substitute, extra substitute, right? So extra substitute is always preferable. So you should be going towards this set, 4 and 5. Okay. So what is the name now? You'll have this as on third position, we have something like an ethane. So it is written as 3 ethine ethynyl. Fourth position, I have methyl, and then we have pent 4N 2 all. 4N 2 all. Done. See the next one. This time while going numbering, I have to give more priority to alcohols. So your numbering should be always given from left to right. So 1, 2, 3, 4. Correct. Now you have to go it in this direction because you are getting it at lowest locants. This double bond is coming at lowest locants. So your the name should be 4 ethynyl, 4 ethynyl, correct? And this is hex 4N, 4N, correct? 4N and 4 in 2 comma 3 diol, 4 in 2 comma 3 diol. Now notice that E I have introduced again. Check that E is present now. Okay, why? Because it is followed by D. See the next one. You have to start with alcohol as a main functional group, then give the priority to double bond. So like this. So what do we have? 6 bromo, 6 bromo, then cyclohex, 2 in and 1 all, 2 in 1 all. Next one I gave just for reference to understand the di-ene form, how to write out. Okay, you can see 5 bromo, cyclohexa, 1 comma 5 di-ene completely and 1 3 diol. Okay, see the eighth one. Eighth one got to be numbering wise. If you notice, we have 1 here, 2 here, 3 here, 4 here, 5 here, and 6 here. Okay, and then we have cyclohexa, cyclohexa 3 comma 5, correct? Sorry, 2 comma 4, not 3 comma 5. 2 comma 4 die-ene completely, and then I have 1 comma, sorry, I have written it wrong. Alcohol should be first priority. 1, 2, 3, 4, 5, 6. Alcohol should have been the first priority. So yeah, it is 3 comma 5 only. So you should have 3 comma 5 di-ene, 1 comma 2 diol. Right. So that should be the name. Please check. Everybody finished? Next. See the next one, next concept. You have same functional group, but the naming is different. See, the suffix naming is different in both the cases. For instance, here, the numbering will start with this carbon. 1, 2, 3, 4, 5. So here, it went right to left. So that's why it has become pentanoic acid. Pentanoic acid. And now you remember why I removed that E again. So the E was removed because it is continued with an vowel sounding letter. Okay. So it is pentanoic acid. But the second one, if you notice, the problem here is I can't keep the numbering for this carbon at any case. That's why the numbering will start with the cyclohexane position here. So 1, 2, 3, 4, 3, 4, 5, and 6. So the name should be cyclohexane, cyclohexane, correct? Complete name, and then carboxylic acid, or you can write it as 1 carboxylic acid. So you can write it as 1. 1 is default, even if you do not write it is fine. So cyclohexane 1 carboxylic acid. So you cannot use oic acid anymore. Now you have to use carboxylic acid. The reason being that carbon is not being counted as a part of the main chain. So when the carbon is not counted, you should, separately write them as carboxylic acid. Okay. See, next one. If you have two COH, again, priorities for two COH, starting with here 1, 2, 3, 4, 5, 6. If I move anti-clockwise, counterclockwise, I can get lowest locants and acids as well as lowest locants and double bonds. Now, what do we write? Cyclohexa and 2, comma 4 diene. First write the complete diene form. Then on 1, comma 2, I have a dicarboxylic acid. It is dicarboxylic acid. Ishman, is that clear? Next. Check out. In case if the functional group are more than two, that means you have more than two carboxylic acid, like 4 carboxylic, 5 carboxylic, 3 carboxylic acid we have on a straight chain, then the alkane is always chosen as the parent chain. Okay, more than two, remember, not two, more than two it should be. So in the first case, there is no problem. The numbering will go like this: 1, 2, 3, 4, 5, 6, 7. So the name will be heptane 1, comma 7 dioic acid. So no problem here. See the second case. When you have like this, in the old IUPAC, we used to call like this, that is 4 carboxy, because you can write it from here. You can write it from here: 1, 2, 3, 4, 5, 6, 7, like this. So, and we can write it as at the 4 position we have carboxy, then 2,6 dimethyl heptane 1, 7 dioic acid. Clear? This is an old IUPAC name, correct? But the new IUPAC name, correct, will not be like that. It will be, if you have more than two functional group, more than two same functional groups, then you will be reading the alkane as the main chain. So 1, 2, 3, 4, 5, 6, 7. Correct. So this will be 7. So it is heptane. So you write down that first. It is heptane. Okay. And on 2, comma 4, comma 6 position, I have tricarboxylic tricarboxylic acid. All right. Just a second. So I guess all of you understood that how to write the carboxylic acid cases in case if you have multiple ones, more than two. See the second case also, how we put the numbering now. Try to go to the lowest locants here. So 1, 2, 3, 4, 5, 6, 7. So you'll be writing this as again heptane. Okay. Oh, sorry. Here if I go like this, I get how many substitutes? 1, 2, 3. Here I'm getting 2, 3, 4, 5. 2, 3, 4, 5. So this is not getting priority. So I should be giving priority like this. 1, 2, 3, 4, 5, 6, 7. Now you are giving the priority to this asset, and this asset. Now notice at any point of time, you will not be able to provide any priority to this COH, correct? Because that is not a part of the main chain, that is not directly connected to the main chain. So this COH can only act like a substitute. So if it's a substitute, what is the name we can write? We can write it as, on fifth position, I have a carboxy connected to a methyl group, isn't it? So it is a methyl substitute, by the way. This is CH3. On a methyl, you have a substitute. That's why we write it as 5 carboxy like this in bracket, just to make sure that you understand it is a complex case. So 5 carboxy methyl, then it is heptane, and at 2 comma 3 comma 6 we have tricarboxylic acid. Tricarboxylic acid. Yeah, I suppose this part is clear, everybody. Done. Now let's see, how do we write the esters, everybody. So this is an ester form. In esters, there is one important rule that need to be followed. Ester is this functional group, correct? C double bond O. Up to this is a functional group. On the oxygen side, whatever alkyl that is present according to the rule, that need to be always written first without any numbering. We should not give it any numbering, but we should write its name first. What is it present here? Methyl. So write down that thing is the first name here. So it is methyl. You start with methyl. Then now go to the other part of the chain. This side we have, and then give the numbering. So here we start with 1, 2, 3, 4, 5. So this is that longest chain. And on second position we have methyl. So 2 methyl, and this is pent, correct? So 2 methyl, this is going to be pent. Pentan O8, because O8 is the suffix for esters. Pentan O8. Keep writing simultaneously, everybody. Check. It is methyl 2-methyl pentanoate. The first methyl is connected to oxygen, so no numbering. Now listen, second one. You have two esters now. On two esters, this side also there is methyl, left side also there is methyl. When you have same methyl groups, I mean when you have same alkyl group, you will write only once, you will not write two times. So you'll write it as methyl, only methyl. So it is understood that there are two methyls on, one methyl on the left side, one methyl on the right side. That is understood. Okay, methyl, then give the numbering. 1, 2, 3, 4, 5, 6. So it is 6 carbon, hence it is hexane, correct? So hence it is hexane. And 1 comma 6 dioate, correct? So I didn't stop at hexane, I went all the way to hexane. So you remember why I wrote that E. Clear? Next, check out this one. This time we have a methyl also and ethyl also. So without giving any numbering to that particular value, you will write it as Alphabetically, ethyl will come first. So you'll write it as ethyl methyl. Then you come back and start numbering 1, 2, 3, 4, 5. So ethyl methyl, and thereafter what do we have? This is pentane, complete in 1 comma 5 dioate. So it will become 1 comma 5 dioate. So Diksha, are you following, Bache? Any doubt?
No, sir.
Right. Yeah, check this out, everybody. Let me go ahead. See, next one. Here, the same logic applies, just like how carboxylic acid, this carbon now cannot get a numbering of a parent chain. Therefore, the numbering will start from here 1, 2, 3, 4, 5, 6. So we write those names here, and whatever that is on the esters oxygen, that is to be written first. So what do we write? Methyl first. Methyl first, and then on second position I have ethyl, and it is a cyclohexane. It is a cyclohexane, and on one position I have uh, ester. So that is read as carboxylate. It is read as carboxylate. It will not be. You cannot write it as O8 anymore. Correct? That's why we write it as carboxylate. Here also same problem. When you have more than two functional group, so you cannot use them for their numbering. So for parent numbering, we'll start from here. So 1, 2, sorry, here. 1, 2, 3, 4, 5. This is a numbering you will start with. All three has methyl, so we will simply write it as methyl. So methyl, and then we will have pentane here. So methyl, then we have pentane, and 1 comma 3 comma 4 tricarboxylate. So it is tricarboxylate. Now, by chance, if you have a different group, can you see now ethyl, one is given is ethyl, the other one is methyl here. So 1, 2, 3, 4, 5. But here, so far we haven't been writing any numbering here, correct? So now what you can do, you can write this methyl, and this ethyl with the wherever it is connected with the same numbering here, but with a prime on it, like this, with a prime on it, just not to confuse with others, like this. 4 prime ethyl, okay, 4 prime ethyl, then 1 prime, 3 prime dimethyl, dimethyl. Then we have pentane, clear, and we have 1 comma 3 comma 4 tricarboxylate, tricarboxylate. Okay, so make any doubt? Right. Now slowly I'm entering into the mix of multiple functional groups. If you have more than one functional group, how do we decide on that? Okay, you know that Priority wise, carboxylic acid is always more prioritized than esters. Correct? Carboxylic acid has more priority than esters. In such case, what we do here, correct? Check it out. Here we have acid, so numbering has to start from here 1, 2, 3, 4. Correct? And you should still search for the longest chain, which is 5 here. So 1, 2, 3, 4, 5. On the fourth position, we have this substitute O C double bond O CH3. This is the substitute which we have. So how do we read it? So we read it like this. On fourth position, I have ethanoyl. Ethanoyl. Ethanoyl is CH3 C double bond O. Correct? Ethanoyl, and oxygen is present, right? Up to this part, it is ethanoyl. CH3 C double bond O is called ethanoyl. And then we have oxygen with it. So we call it as oxy. Ethanoyl oxy with pentanoic acid. Pentanoic acid. Now the new IUPAC, what they have assumed, wherever there is ethanoyl, right? This is basically CH3C double bond O. CH3C double bond O, in lot of cases we'll use the word acetyl. Okay, acetic acid, acetyl group connected, correct? So that has become that has become so common that it is now a part of IUPAC naming also. So all the new IUPAC, new compounds with writing IUPAC, we write it like this: 4-acetyl oxy, acetyl oxy pentanoic acid. Okay, both of them are correct. The second one is these days more accepted. That's it. Okay, clear? See the next one again. Okay, we have very similar case here. Correct. Now this is ethanoyl oxy at this position. So first, let me number them first. We have 1, 2, 3, 4, 5, and 6. On the fourth position, we have ethanoyl oxy. So we'll write it that first. Fourth, ethanoyl oxy. And on the third position, now C double bond O is directly connected. Instead of earlier how it was directly connected. So in that case, what do we write? OME is methoxy. This is methoxy. And that methoxy is connected to carbonyl. So we read it as methoxycarbonyl. Everybody understood? We write it as 3-methoxycarbonyl, then cyclohexane, correct? Cyclohexane, where 1 carboxylic acid. 1 is default, even if you do not write, nothing will happen. That is correct. Carboxylic acid, cyclohexane, carboxylic acid. Okay. You can write the same name, everything is same here, correct? As per new IUPAC, only one thing you can change here. What is that? Acetyl form, that's it. So here you change that. Instead of that, we write it as 4-acetyl oxy. Acetyl oxy. I guess the name is clear, everybody. Done. Check out acid halides now. Acid halides, we name it like this: alkyl OL halide. Like this, butanoyl chloride. Okay. Alkanoyl chloride. Anything which will be there, it is read as alkanoyl chloride. If you have multiple groups here, there are three C double bond O Cl. Told you when you have more than two groups, then alkene will become the main chain. So this is 1, 2, 3. This is the main chain. So we write it this way. It is propane. It is propane 1, comma 2, comma 3. We have tri 1, comma 2, comma 3. Tri carbon oil. Carbon oil. Okay, chloride. Carbon oil chloride. Otherwise, it is simply oil chloride. Now this will become carbon oil chloride. Next one. See the next one. When C double bond of Cl is used as a substitute, what do we name it? Okay. I took one case here. So how do we write that? First, let us put the numbering. So we have 1, 2, 3, 4, 5, 6. Because double bond should be given more priority once the functional group is decided. COOH is the main functional group. Based on that, next priority is double bond. And now on the sixth position, we have, group connected here. So sixth position, I have group connected where you have C double bond O. C double bond O is read as carbonyl, correct? But it has chloro on it. So we write it like this, chlorocarbonyl, chlorocarbonyl on sixth position. And this is cyclohexene. Okay. You have to write it as complete ene, then carboxylic acid. Then it will become carboxylic acid. Okay. Everyone finished? Everybody finished writing? Notice next one. If you have acid amides, what do we name it? So in simple straight chain with carbon as a counted carbon, then it is ethanamide, right? So if you have two carbons also, will still be counted. So it will be 1, 2, 3, 4, 5. So it is just basically diamide. So what is the name like? Here it will become pentane 1, comma 5 diamide. So 1, comma 5 diamide. Okay. Next here, if you notice, we have one, this time, right? No, not from this end, this end. So we have 1, 2, 3, 4. So that is the main chain. So that will become butane. So it is butane, and I have 1, comma 2, comma 4. 1, comma 2, comma 4. Try carbox. You use the word carbox. Carboxamide. This time we use it as carboxamide. Now, if it is amide as a substitute, what do we use that? Okay. So here again, numbering wise, 1, 2, 3, 4, 5, 6. So the name, what do we use it? 2, on 2 position, I have aminocarbonyl. 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 Then third position, we have methyl. Correct. And this is cyclohexane, complete name, and then carboxylic acid. Finished? Next, see the next compound here. In this case, numbering must start from the main functional group, which is amides. And on the amides, on the nitrogen end, there are groups connected. So you'll represent that with letter N. So it is N-ethyl, N-methyl, N-ethyl, N-methyl. This is butanamide, butanamide, N-ethyl, N-methyl, butanamide. Okay, N-ethyl, N-methyl, butanamide. Next, if you have cyanides and isocyanates, how do we name it? See, CN, cyanide as a functional group name is nitrile. And because it is starting with a consonant, every time in a function you write down, you have to write the complete name. So it will be pentane nitrile, butane cyanide. But butane cyanide is not a preferable IUPAC name. So just mark it like this. So it will always has to be nitrile. Now, similarly, if you have multiple cyanide groups, here also the numbering goes from alkane 1, 2, 3. So you could notice what is the name given. Propane 1, 2, 3 tri carbonitrile. This time we write it as carbonitrile. Okay. So this is carbonitrile. See here, the naming should be, this is a acid group here. So acid is more priority group. So 1, 2, 3, 4. Correct. Now this entire thing cyanide is taken as a group. Okay. So that's a cyano group. So we will have this as 2, comma 4 dicyano. Dicyano. This is butanoic acid. 2, comma 4 butanoic acid. Right. Now notice the last one. If you have an aldehyde with multiple CHO groups, more than two CHO groups, again, whatever with the logic we'll just learn, apply that. We have to write it as 1, 2, 3, 4, 5. So it is basically a pentane. So you write the name here, which is pentane. And on that pentane, we have 2, comma 3, comma 4 tricarb aldehyde. So you use the word carb aldehyde. Okay, otherwise we simply use it as al. Okay, I hope all of you got this right. Right. So we'll stop it here.